transfer the current from one place to another place. Now you can see the principle and construction of the transformer. So transformer, the device used to see that. So transformer, you are giving the input to the transformer. So we are giving the input electrical signal to the transformer, that is given into output electrical transformer. Output to give the output. Okay, this is a function of the transformer. So input current given to the transformer to give the output current. So but it will vary for the two types. It has the two different types of transformer. So using that we can transfer the current. So see now here that input current is a step down transformer. So step down transformer, input voltage is maximum but output voltage is minimum. But input current is low but output current is maximum. So this is called a step down transformer. Step up, so here P in equal to P out means power in is equal to power out. So power in equal to power out means P equal to V into I, you know that. So see that conductor is connected to the battery. What will happen? Current flow through the conductor. According to the Hans Christian Ørsted, that magnetic field is surrounded by the conductor. So the current is surrounded by the conductor. Okay, that's a magnetic flux is there. So when armature, that is another one conductor is connected to the galvanometer, when it is passed near to that what will happen? An EMF is induced. So this is some method of producing the induced EMF. Okay, so I2 is produced in the secondary coil, so it will show the reflection. It's a one method. So this principle is used in the transformer. So electromagnetic induction, that principle used in the transformer. So principle of the transformer is electromagnetic induction. That is the principle of transformer. Okay. So from that, principle used in the transformer, it has two types of transformer: step up and step down. Step up transformer means it will increase the voltage, decrease the current. Step down transformer means it is decrease the voltage, increase the current. Here voltage and current is inversely proportional to each other. So according to that power P equal to V into I. Power is equal to V into I. Power we calculate multiplied the voltage and current. P equal to V into I. So here input power is equal to the output power. So input power is equal to output power, but the voltage is changes. So induced EMF E equal to d pi by dt according to the Faraday's law. So this principle is used in the transformer. So methods of improving electromagnetic coupling. So methods of improving by using the coils on both sides instead of using single wire. So instead of using single wire, you are using the coil. So ஒரு காயில இருந்து இன்னொரு காயில மேக்னெட்டிக் ஃப்ளக்ஸ் கட் பண்றதை விட அதை வந்து ஒரு காயிலா யூஸ் பண்ணோம்னா, கண்டக்டரா யூஸ் பண்றதை விட காயிலா யூஸ் பண்ணோம் அப்படின்னா can improve the transfer the current from one coil to the another coil. You can see that two coils are there. One coil is called the primary coil, another one coil is called the secondary coil. So P1, P2. P1 is the primary coil, P2 is the secondary coil. This is a step up transformer because see that number of turns in the secondary coil is greater than the number of turns in the primary coil. See the number of turns, it's not equal, it's different. Secondary coil, number of turns in secondary coil is greater than the number of turns in the primary coil, so it is called step up transformer. Suppose number of turns is very less in the secondary coil compared to the primary coil, that is called step down transformer. For step up transformer, voltage is maximum. It gives the high voltage but low current. So input voltage is low but output voltage is maximum. Input current is high but output current is less. But total power is equal to constant. P equal to V into I. So input power is equal to output power according to law of conservation of energy. See that number of turns in the primary coil is greater than the number of turns in the secondary coil. This is called a step down transformer. So input voltage is maximum but output voltage is less. But input current is less, output current is maximum. So this type of transformer is called a step down transformer. So two types of transformer. One is a step up transformer, another one is a step down transformer. So it is a coil. that coil is wounded over a metallic frame. It's made up of metal. It is increasing the magnetic flux. It's a insulated slide is there. Already you know that eddy current. Due to the eddy current loss, to reduce that, the insulation metal sheets are used in the transformer. எதுக்காக அப்படின்னா eddy current reduce பண்றதுக்காக. It is a thin metal sheet. Insulated sheets are used in the transformer to reduce the eddy current. You know that insulated material reduce the eddy current and holes. Okay, that two things are reduce the eddy current. That's why in transformer that metal, new metal or silicon metals are used in the transformer to reduce the eddy current. That's why we are using this plate type. So combining all the plates can produce the transformer that material, inner material. Above that inner material we are going to wound over the coil, primary coil and the secondary coil. So these are all the metal strips. It is not a bar like a very big metal. It is a sheet. Sheets are combined and form a inner core of the transformer. So this is the transformer core. So the coil is wounded over the core like this. So primary and the secondary coils are wounded over this metal. It will helps to reduce the eddy current and the flux loss. It's a thin sheet. It is insulated. So coil is wounded like this, the primary coil and secondary coil. So method of making the transformer, primary coil and secondary coils. So to minimize the eddy loss, we can cover wounded over the coil like this also. That another method. You can able to see this type of transformer near your home. See that one primary coil and small gap is there and secondary coil. So this electronic device also you can able to see this. This is inside the TV and all electrical devices. We used to step up or step down the current and voltage. Okay. So next we are going to see the transformers, principal construction and working of the transformer. So it's a two coil, primary coil and secondary coil. So soft iron core is between the primary and secondary coil. Laminated iron core to reduce the eddy current loss. An AC input is given to the primary coil, and you can get the output in the secondary coil. So current is given to the primary coil. It will produce the magnetic flux. It will produce the magnetic flux. That magnetic flux is cut by the secondary coil. So when the magnetic flux is cut by the secondary coil, EMF is induced. So induced EMF produces the current in the secondary coil. Principle of a transformer. So it's an electrical device. Current low alternating voltage into high alternating voltage. That is step up transformer. That's the use of the transformer step up, step down. So see the electric power of the primary and the secondary coil. So principle of the electromagnetic induction. So what is that? So now induced EMF in the primary coil is EP, secondary coil ES. Number of turns in primary is NP, secondary is NS. Okay, so the number of turns is greater in the secondary coil compared to the primary. So it is a step up transformer. So step up transformer, since the same flux. Okay, that since same flux links with the primary and secondary coil, EMF is induced for the turn in two coils must be same. So EP by NP, EP by NP, EP is nothing but voltage by the number of turns cut by the coil, is equal to ES by NS, or we can write EP by ES. ES inga keela kondu vandam. So ES by EP equal to NS by NP. So NS by NP, you can take another say equation number 1. Right? The next thing is it's a E means that is induced EMF. In secondary coil, EP is the primary coil, number of turns in secondary coil, number of turns in the primary coil. So for an ideal transformer, input power is equal to output power. It's an ideal transformer. EP, IP equal to ES, IS. That is power. P equal to V into I. Instead of V, V means potential. Here EP is the potential. EP and ES. Where IP and IS are the current in the primary and secondary coil. Input power equal to output power for only the ideal transformer. But in a other transformer, there is a loss in energy. Okay. So here ES by EP equal to IP by IS. Already we derived this equation. So equating these three equations, 2 and 1. So ES by EP equal to NS by NP. Already we know that. Here also ES by EP equal to IS by IP by IS. So writing this IP by IS equal to get the K, that is called transformer ratio. So transformer ratio, for step up transformer K is greater than 1, and step down transformer K is less than 1. Okay, K is greater than 1 and K is less than 1 for the step down transformer. So by using the transformer ratio, we can identify whether the transformer is a step up transformer or step down transformer. So K is called transformer ratio. For ideal transformer only, input power equal to output power, but other transformers there is a energy loss. Okay. So in a step up transformer, number of induced EMF in the secondary coil is greater than the primary coil, implying that output current is very low compared to the primary coil. Thus the step up transformer increases the voltage by decreasing the current, which is accordance with the law of conservation of energy in step up transformer. In step down transformer, decrease the voltage by increasing the current. So efficiency of a transformer. Efficiency of transformer is defined as the ratio of output power to the input power. Ratio of output power to input power. Power equal to V into I. So ES IS by EP IP. So power nale voltage into current. Here ES applicable voltage. ES IS by EP by IP. So that is a eta. That is eta called the efficiency is 100% for ideal transformer only. But practically there are numerous factors to leading the energy loss in the transformer, and hence efficiency of that transformer is always less than 1. It is not equal to 100%. It is always less than 1 because there is some energy loss in the transformer. So now we are going to see what are the energy loss in the transformer. So what are the energy loss in the transformer?
A transformer.
So energy, the first one is hysteresis loss. Hysteresis loss means converting that magnetization and demagnetization. When the current flows through the coil, it will become a magnet. When you stop the current, it will demagnetize. So magnetization and demagnetization occurs continuously. Due to that, it losses. That loss is called hysteresis loss. This loss can be minimized by using a core with a material having the least hysteresis loss. So mu metal is an example for least value, and silicon steel also. So this is the first energy loss, hysteresis loss. Next one is the copper loss. So we are using the copper in a primary, secondary coil, whatever it is. According to Joule's law, H is equal to I square RT. So it loses that electrical energy in the form of heat energy due to resistance of the copper wire. So reduce that, we can increase the thick wire. Then eddy current loss or iron loss. So when the current flow through that coil, it produces a magnetic field. Magnetic field produces the eddy current on the material. So eddy current is dissipated in the form of heat energy. To prevent that, we can use the insulated strips. Insulated metal strips. It is not a thick metal, it is a strips. Last one, flux loss. A magnetic flux produced by the primary coil, it is not completely cut by the secondary coil. There is a loss in energy. So to prevent that, we can use the shell type core. Okay, we can use the shell type core like this. So inner side is a primary, outer side is a secondary. So if this type of coil is used, means we can reduce the energy loss. So we can use the shell type core. So due to the vibration of the core, sound produced which causes losses in the energy. We prevent all the energy loss, but small amount of energy is losses in the form of sound energy. எல்லாத்தையும் நம்ம கட் பண்ணாலும் கொஞ்சோண்டு எனர்ஜி என்னவா வேஸ்ட் ஆயிடும் அப்படின்னா சவுண்ட் எனர்ஜியா வேஸ்ட் ஆயிடும். இப்போ என்ன பண்ணோம் அப்படின்னா ஒரு எலக்ட்ரிசிட்டி ப்ரொடியூஸ் பண்ணிட்டோம். ப்ரொடியூஸ் பண்ண எலக்ட்ரிசிட்டி கொண்டு வரதுக்கு டிரான்ஸ்ஃபார்மர் யூஸ் பண்ணுறோம். அது எப்படி கொண்டு வருது? பவர் லாங் டிஸ்டன்ஸ் டிரான்ஸ்மிஷன். அடுத்து நான் பார்க்க போகிறது லாங் டிஸ்டன்ஸ் டிரான்ஸ்மிஷன். லாங் டிஸ்டன்ஸ் டிரான்ஸ்மிஷன் அப்படின்னாலே இப்போ வந்து கரண்ட் வந்து நம்ம வீட்டு பக்கத்துலேயே ப்ரொடியூஸ் பண்ண கிடையாது, பவர் பிளான்ட்ல பண்ணுறாங்க. இப்போ அங்கேருந்து இங்கே கொண்டு வரணும். அப்போ எப்படி கொண்டு வருது அப்படின்றத இப்போ நம்ம பார்க்கலாம் ஒரு இல்லஸ்ட்ரேஷனோட. So now you can see that long distance power transmission, that is a power station. So from the power station we generate the electric power. So by using the transformer we can give it to the domestic purpose and industrial purpose. So this is the power transmission lines. So they are transmitting the power through the wire, aluminium wire. How do you know that everything? They are transmitting the power through the aluminium wire. So if that current through that wire R is resistance, a considerable amount of electric power I square RT dissipated as a heat. அப்போ ஹீட் எனர்ஜியாக வெளியில் போயிடும். இப்போ பாருங்க, இது வந்து ஜென்ரேட்டிங் ஸ்டேஷன். ஜென்ரேட்டிங் ஸ்டேஷனில் ஸ்டெப் அப் டிரான்ஸ்ஃபார்மர் யூஸ் பண்ணுறோம். ஸோ we can step up transformer means we can increasing the voltage, decrease the current. Then சிட்டிக்குள்ளே வரும்போது we are using the step down transformer. It will decrease the voltage, increase the current, and then it is given to the house. Okay, when the power is transmitted through that wire, it loses in the energy in the form of heat energy. According to Joule's law, H is equal to I square R, dissipated as a heat. So to prevent that, we can increase the voltage and decrease the current. So hence the power of receiving that will must be lesser than the actual power generated. So நம்ம ப்ரொடியூஸ் பண்ணுறத விட வீட்டுக்கு வந்து சேர்ந்து ரொம்ப கம்மியாக இருக்கும். Because I square R, that is loss of heat energy. Then however, that transmitting that energy, that power P equal to V into I. So one illustration to explain the energy loss. Power P equal to V into I. Power equal to 11,000 watts. Transmitted 220 watt. So I is equal to 50 ampere. I equal to P by V. So it's a 50 ampere. So 50 ampere current is flowing through the wire. So by using the power loss, I square R equal to 2,500 watts. So that is the energy loss by converting that into 220 volt. By increasing that to 22,000 volt. See here, it is increases up to 22,000 volt. அப்படி increase பண்ணோம் அப்படின்னா the flow of current equal to 0.5 ampere. So the loss is 0.25 R. See here, 220 voltல transmit பண்ணா இவ்வளோ லாஸ் ஆகுது. 20,000 voltல பண்ணோம் அப்படின்னா இவ்வளோ வரும். அப்போ ஹை வோல்டேஜில் டிரான்ஸ்மிட் பண்ணோம் அப்படின்னா எனர்ஜி லாஸ் வந்து கம்மி. So that's why by using the step up transformer we are increasing the voltage, decreasing the current. So hence it is evident that if the power transmitted at a high voltage, the loss of energy in the form of heat can be considerably reduced. So only we lose that very small amount of energy. Okay, so it's a transmission of power from power plant to the domestic and the house purpose.